Hey guys, welcome back to my YouTube channel. And in this video, we are going to talk about time series analysis. In fact, I have been thinking about making a series of videos on this particular topic as it is a huge topic and a single video is no will not be enough to include all the important concepts about it. So I will be uploading them on YouTube for free and you just need to track them on to understand all the concepts related to it. So before starting this video, I just want to request to you that if my videos are helping you in any sort of way, then do subscribe my channel and like my videos because that gives me motivation to keep making these kind of videos again in future. So let's start the video. So for this particular video, you need to have these requirements because I'm going to use these tools in explaining the concept in this particular video. So first of all, you need to have some amount of knowledge about Matplotlib and Seaborn, which are essential libraries for making graph and charts in Python. And then you also need to have some knowledge about Pandas and NumPy. Pandas is a beautiful library for data frame manipulation, and on the other hand, NumPy is basically used for mathematical calculation. And I'm going to perform some of the mathematical calculation in this video and in future videos also. So you need to have these. You need to have knowledge about these libraries. After that, you also need to have some good understanding of mathematics because all the algorithm are based on mathematics. If you have strong foundation in maths, then definitely it's going to be easy for you to understand all the concepts. Now, the fourth and the most important point that you need to have is a strong will and patience because this particular video is going to contain a lots of theory and it might be problematic for some of my viewers because a lot of theory make this video boring, but you need to understand that in order to jump to the practical part, you need to first build a strong foundation in theory also. So with that, let's start the topic. So first of all, I'm going to explain you what is time series data. As you can clearly see here that we have a data frame containing date column here and few other columns which have some kind of information in it. But if you look closely, then you will find out that this particular date column has a sequence in it. The first row has one that is 1st January 2013 and then 2nd January 2013 and 3rd January 2013. So first of all, you can conclude that this particular date column has a structured way, an ordered way, and all the dates are here in a chronological order. It's from starting of the month to the ending to the end of the month. And then all the other columns like mean temperature, humidity have information about that particular date. So it is the mean temperature for January 1st. It is the humidity for January 1st. It is the wind speed for January 1st. So all these other columns are giving us information for that particular date. So a time series data is always be going to be like this. Okay. Here I have date column, but it might can happen that you will get a data set where there is no date column. Instead of this, you might get time here. That kind of data is also known as time series data. For example, let us suppose you get a data in which here one column is time and one column is number of visitors in your shop in your shop. Okay, right. Now at 9 a.m., suppose you have 200 visitors. At 10 a.m., you have 250 visitors. At 11 a.m., you have 300 visitors. So this kind of data is also uh, comes under time series data. So in time series data, in simple language, a time series data is a data where there is one column which has either date in a structured way or ordered way, or you can have time in an ordered way, and all the other columns are giving us information about that particular date or time. So that concludes the time series data. If we come to the uh, definition part of it, then you can clearly see here that time series data is a sequence of data points at specific time intervals over a period of time, which used to track changes, trend patterns across the data across time. Okay. Now, if we jump to the characteristic, the first and most important characteristic is that the observation are recorded at regular interval. And it is a very beautiful point because here you can see that there is no jump between any two dates. Dates are ordered sequentially, and if the data is given for 1st January, then it is also given for 2nd and 3rd and 4th. There is no jump. Like you cannot jump from 1st to 3rd directly. So the data should be for each and every date. Okay, that is the ordered way. If in your data set you get a observation for first, and then directly for third, and then for fourth, then for fifth, then you first need to fill the observation for the second also by imputation. You can use mean, median, or any other method to find the observation for second also, so that you can make the whole structure in an ordered way, and only after that you will make your time series data ideal. Okay, so that is the first characteristic. And the second characteristic, that the order of the data matters, which simply means that you cannot arrange the date or time in any order. Like I haven't arranged here the date into just like this: 5th gen, then 4th gen, then 10th gen, and 5th gen. This is unordered way of structuring the dates column. But in time series data, you do not have to do this, because this is not the ideal scenario. Why this is not the ideal scenario? It's simply because all the machine learning algorithm in time series data assumes that the observation are recorded in an ordered way, so they need all the observation sequentially from oldest to earliest to latest in simply means. So you always have to short short your data frame short your data frame by date or by time, right? Like here I have sorted my data according to date. It is going from the start of the month to the end of the month. So the order of the data definitely matters here. Okay. And as I already gave you this particular example, you can have many examples. Like you can record daily temperature, humidity, rainfall over time. You can also record number of visitors per hour or per day. You can also record GDP per year or per month or per quarter. It's totally depend upon you how you want to record the observation for your time series data. Okay, you just need to uh you just need to you just need to uh, control that all the observations should have the same time gap, uh, and all the time or date should be ordered in a particular sequence, just that. After that, let's come to the second slide, and here how to draw a time series data. So first I'm going to tell you that how you can draw it manually, but after that we are not going to draw it manually in all the cases. First, for example, we have a data frame here. Like here we have hours, here we have visitors. So here, let's suppose at 9 a.m. I have 200 visitors, 10 a.m. 350 visitors, 11 a.m. 100 visitors, 12 p.m. 250 visitors. Like now, you can just simply put the hours in x-axis and visitor on the y-axis, and then you have to just plot these points like 9 a.m., 10 a.m., 11 a.m., 12 p.m. And here you can just 100, 200, 300, 400. So here 250 will come right here, 10, 350 here, 11, 100, 12, 250. Okay. Now this kind of plot is known as scatter plot, but in time series data we always have to draw a time line plot. Okay. Now you have to connect this point with the help of a let me just take another color, yeah, like that. Now this line gives you insight about your time series data. How you can find insight from this particular line? It is just simply showing us that the number of visitors is increasing between 9 to 10, and then it's decreasing from 10 to 11, and then it's again increasing from 11 to 12. So this is how you manually draw a time series data. But in actual case we don't have to do it manually, because we have already studied so much Python, and we already know about matplotlib and seaborn. We are going to use it to draw it. Okay, so I'm going to show you directly in my code. Let me take you the code. Here I have first imported all the essential libraries. As you can see here, I have imported matplotlib and seaborn, which are essential for plotting. And then I have imported the dataset, and as I already this dataset I already showed you. And then after that, I just converted my date to datetime format, and then I check that the date should be in ordered format, and it is in a sequence, so that's good. Now I have used line plot from Seaborn library, so you can just draw a time series. I have just drawn a time series data for mean temperature here. As you can clearly see that y-axis contain the mean temperature and x-axis contain the date. So I just want to track here that how the temperature is behaving throughout different years. Okay, as I draw a line plot between the date and the mean temperature, I get to know that the mean temperature is slightly increasing, and then it is increasing, then it decreasing, increasing, and then it decreasing. And if you look closely, then you will see that it is increasing uh, after 6 or 7 months, and then at the end of the year comes to the same point, and then for the next year it is behaving the same as has behaved earlier. Okay, so by that I can find various kind of insights that throughout the year the temperature is increasing and then decreasing, and it is actually making sense because we know that if we live in India, we know that during the summer the temperature increases, and then winter, and in winters it decreases. So that observation is making perfectly sense here. Okay, so here I have shown you how you can use libraries to plot a time series data, and you can find insights from it. Okay, now let's jump to the next slide. As I have already shown you this. Okay, I'm going to give this particular PPT to you, and you can just go through it and do whatever you want. Now, we have to understand the characteristic of the time series data, and it is very important for you to give your 100% attention to it, because all the upcoming videos about the time series data in future are going to have some heavy concepts, and those concepts are built upon these particular characteristics. So if you just get these characteristics into your mind, then it is going to be a very beautiful journey for you in the upcoming videos. Otherwise, you might not be able to understand each and everything I'm going to teach in future. Okay, now the characteristic of a time series data. So as we can see here, there are 7 characteristics. First is time dependency, trend, seasonality, cyclic patterns, stationarity, autocorrelation, and irregularity. So I'm going to talk about these characteristics in each slide, and you just need to pay attention to it in whatever way you want to. Okay. So first, time dependency. We have already talked about this, that in a time series data, the order of the time matters. Okay. So first point we have already discussed, but the second point is very very important. It is saying that the observation at different times are not independent but depend on the past values. So that means the observation we are taking in a time series data should always depend upon the past values. Let me try to make you understand that how important it is with the help of this table. Like, if we take the mean temperature of 3rd January, it is 7.1. So according to this second point, it is saying that the mean temperature at 3rd January should depend upon its past value. Past value means it should depend upon the temperature of the 2nd January, and the temperature of the 2nd January should depend upon the temperature of the 1st January. So, in simple words, each observation should be dependent on all of its past values. And why it is so important? So, if I just try to make it simpler, you need to understand that why we are studying time series data. Because simply because we are trying to build a prediction model, right? We are trying to prediction model. We are going to train our machine learning model with the help of this data. Okay, right? With the help of this data, and after training with this particular data, we are going to make prediction about the future, right? Let me just change the color. For example, I have trained my machine learning model. I have trained my machine learning model with 9 rows. So I know the mean temperature at 10th January is 11. Now I want to predict that what will be the mean temperature at 11th Jan. So I'm going to predict this temperature with the help of machine learning model. Right? Now just try to understand that each machine learning model, each any machine learning model always try to find patterns inside your data points, right? So my machine learning model will try to find pattern inside these observation. But if these observation are independent of each other, so that means they are randomly oriented, they are randomly written. So that simply means there are no patterns. So how my machine learning model will be able to predict the future? So because of that, each observation should be dependent on the past value. Only then our machine learning model will be able to find a pattern between the observation. Our machine learning model will be able to find that present value, how present value is dependent on all its past value, and then only it will be able to give us the right prediction. So that's why the observation should be dependent on the past value. Otherwise, our machine learning model is going to perform very badly, right? So I don't know why I just put this chart over here. I think you got my point. So I'm going to just jump into the next slide. Okay. Right. So second characteristic is trend. So trend basically means the upward and downward movement of our data points in long run, very, very long run. So to explain that, let me just take you to the graph. Here you can see that I have plotted average temperature on the y-axis and the time on the x-axis. As you can see that I have made a graph for a very, very long time. It contains all the data points from 1960 to 2000 and also even after 2000. So if I have just made this graph for only 1960, you won't be able to find any pattern in the long run. But as I have made this graph for very, very long time, I can clearly see that my graph is slowly moving in the upward direction. So that means it has a upward slope. And why it is important to a steady trend, because we want to know that in the long run whether our observation are going upwards or it is going downwards, and what these observation might be, it depends upon case to case. For example, if you are studying sales of a company, then you want to find in the long run after 10, 20, 30 years your sales would go up or would go down. So every business want to study trend in their time series data, that how in the long run their time series data is going to perform. So trend basically means upward trend or downward trend, how our time series is going to how our time series is going to behave in the long run. That includes the trend. I think I would be able to explain you. Now let's jump to the third characteristic, that is seasonality. So seasonality refers to the I just want to make it simple. Let me just make it simple. Seasonality simply means patterns that are repeating again and again in your data in a fixed interval. Okay, it is the most important point, that there should be a repetition of pattern inside your data over the fixed interval. Then that repetition of pattern is known as seasonality. For example, you can clearly see that here my data points are going upward and then downward, then upward and then downward, upward and then down, and the this particular pattern is repeating at the same time interval. The time interval between this top and this top is exactly same. The time period between this top and this top is exactly same. So I can just say that this is the pattern which is going to repeat again and again in the upcoming future after this time period. So this particular pattern is called seasonality. So seasonality simply means the patterns that are going to repeat at regular intervals. Okay, if I just gave you a very simple example, you have seen that the sales of conditioner air conditioner AC increases during the summertime and the sales decrease in the winter. Okay, so if you are going to plot the sales of air conditioner throughout year, then the graph would look you like this, right? This will be let me just change the color. This would be summer winter, summer winter, summer winter. So we can just say that this pattern, this particular pattern is going to repeat again again each year. So this particular pattern is known as seasonality. So seasonality simple means the repetition of same kind of pattern within the same time period. Oh, sorry, within the regular intervals, at regular intervals. So that concludes seasonality. Okay. Here I have written some more point. You can just read that. Okay. Now let's jump to the fourth characteristic, that is cyclic patterns. Cyclic patterns. So cyclic pattern is same as seasonality. There is single difference between these two. Seasonality occur at regular interval. On the other hand, cyclic patterns do not occur at regular intervals. Simply means seasonality will be like this. On the other hand, cyclic pattern will be like this. Here you can see that here this. Let me change the color. You can clearly see that this particular pattern is repeating at the same time interval. Okay, same gap. But here this particular pattern is repeating again, but the duration or repetition is not same. Here the duration is very large and it decreases. So this particular thing is known as cyclicity or cyclic pattern. It is different from seasonality. Unlike seasonality, cycle have variable duration. It can have any duration. Okay, because it is in fact it is affected by the external factors. External factor basically means, uh for example I'm just trying to remember an example. For example, just we can just take the example of air conditioner again, but that might not be the right example, but I'm just trying to make you familiar with it. For example, suppose that uh, mm, in a village where there is already cold, already cold, okay, already cold, some of the family buy air conditioners. So the pattern will be like this: 1 year, but after that they do not uh, after that the peoples and in that particular way do not bought in do not buy any particular air conditioner. Now there comes a time when the temperature increases and then they again buy air conditioner. So you can just see that this pattern repeated again, but we don't know that after how much time it's going to repeat again. Okay, I think I have made you confused, but in simple words, in cyclic pattern we do not know after how much time this particular pattern is going to repeat again in future. So that concludes the cyclicity. Here I have already written that in seasonality, repeat at fixed interval, cyclic pattern do not repeat at fixed intervals. So that concludes cyclicity. Okay, let's jump to the fifth point, that is autocorrelation. So, in order to understand autocorrelation, you first need to understand what correlation is. So, if you come from a mathematical background, then you definitely heard about it. What is correlation? But if you are not coming from a mathematical background, that it might be problematic for you. So, for those viewers, I'm going to explain what correlation is, and after that, I'm going to explain this whole particular topic. So, let us first understand what correlation is. So basically in simple word, correlation tells us about the relationship between two between two variables. What kind of relationship? It tells us that if one variable increases, then how the second variable will behave. For example, we can take an example like here. I'm trying to find that on increasing the temperature, how the sales of the ice cream behave. And some of you would simply argue that what kind of question is this? By simple logic, we all know that with increase in temperature, the sales of ice cream should also increase. Yeah, I will say that you are absolutely correct. But in this particular field where we are studying about data science and data analysis, we cannot prove anything without mathematical formulas. We cannot use logic here. We have to support our answer with some numerical form, with some digits. So, to prove our assumptions, we have to use correlation. So, correlation gives us proof that uh, how two variables are behaving with each other. Okay, so that is correlation, and we to find this proof we have to solve this formula. This is the formula to find the correlation between two variables. Okay, now all these alphabetic, what are these? I have just written over here, you can just read them. I'm going to explain you how we can find the correlation. First, I need to erase these things. Okay. So first, we are going to find the correlation between temperature and ice cream cells, right? So for before that, I just want to tell you that the scale of correlation is limited to -1 to 1. Okay. If 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 the value comes nearer to -1, closer to -1, if the value is closer to -1, then we say that it is negatively correlated. Negatively correlated means on increasing the temperature, the ice cream sales will decrease. So negatively correlation simply means on increasing one variable, the other variable will decrease. But if the correlation comes closer to +1, then we will say that it is positively correlated. Positively correlated, which simply means on increasing the temperature, the ice cream sales will also increase. Okay, if the value comes nearer to 0, okay, because I have already told you that the correlation will always come between -1 to 1. So if the value comes between nearer to 0, then either we will say that we cannot say anything with a strong evidence. To have the strong evidence, the value should come nearer to -1 or +1. Okay, more the closer our correlation to -1 or +1, more strong our evidence is. More it is closer to 0, we cannot have a strong evidence to prove our assumption. Okay, so now we are going to find the correlation. Okay, first I need to erase all the. Now, to find the correlation, we have to use this formula, as I've already said. To solve this formula, first we are going to solve the numerator part of it. The numerator says that you have to find each observation from the mean of it. So what is x? X is these observation are x. What is mu x? Mu x is the mean of these all observations. So I have first find the mean of x. So here the means come out to be 32.4. And now I have to subtract each observation from this mean. So here it is. This is xi 30, 32. Here you can see that. Now I have subtracted each observation from its mean. 30 minus 30.4 minus 2.4. 32 minus 32.4, 0.4. And then again. Now I have solved this part. Now it is saying that you have to subtract each observation from its mean again for the ice cream sales. Here, each observation denotes y, and here its mean denotes mu y. So first I have calculated mu y here, and now I have subtracted each of these observation from its mean. So 100 minus 119 minus 19, again and again and again. Now you have to multiply these two terms. So here I have multiplied this. Okay, and then you have to use summation. Summation simply means you have to add all these values. So, okay, right? So you have to add these values. So if you add these values, you will get the numerator part of it. Now we have solved the numerator part of it. Now to solve the denominator part, you have to square all these subtractions. You have to square these and these, all these subtraction. You have to square -2.4 -0.4, 1.6. Again, you have to square -19 -9, because it is written here x minus mu x ka square. Okay, y minus mu x square. So I have done that here. And after that, I get the denominator. Okay, you will get the denominator. And then you have to divide this numerator with this denominator. And after solving that, I get the correlation, which is 0.89, which is very, very close to 1. So we can simply say that the temperature is positively correlated with ice cream sales. So that simply means on increasing the temperature, the sales of the ice cream will also increase, right? So in that way, I have explained you correlation. Now in time series data, we do not use correlation. Instead, we use autocorrelation. Okay. So autocorrelation is used in time series data. Why autocorrelation is used? Because I already told you few slides back, in time series data, each observation each observation should depend on past value, right? Each observation should depend upon the past value, and we want to find that how strongly our present value depends upon past value. And here the scale again will be the same. Here again the scale of autocorrelation will be always between -1 to 1. Okay, so if our autocorrelation comes closer to 1, that means our present value is strongly influenced by our past value in a positive way. If the yesterday temperature is increasing, then today temperature will also increase. If yesterday's sales were higher, then today's sales will also going to be higher. If yesterday temperature was decreasing, then today temperature will also increase, right? But if our autocorrelation comes closer to -1, then we will say that our our present value is negatively auto-correlated with our past values. That simply means if we if the yesterday temperature was higher, then today temperature will be lower. Negatively correlation means opposite. Okay, if the past values were increasing, then today value will decrease. So closer to 1, then both will go in the upward direction or in downward direction. More closer to -1, if one value increases, then another value will decrease. And again, if the autocorrelations comes in between, okay, let me have to. And if the autocorrelation come bit nearer to 0, then again we do not have enough evidence to support our claim. Okay, now to find the autocorrelation between any two observation, we have to use this formula. Now all the other things remain the same except this lag h. So let me first explain you what is lag h. So right now I'm trying to find how my present value depends upon my yesterday value, but we can also find that how today's value is affected by last second value or last third value or last fifth value or last 10th value. So that gap between today's time and that time is known as lag edge. So if okay, let me pray. So if you are trying to find the relation between our present value and last 10th value, how our present value is going to be affected by the last 10th value, then lag will be here 10. So you have to take a gap of 10 between these two values. What I'm trying to say, you are just going to understand it in our next slide. For now, you just need to understand that lag here denotes the interval between the two time frames for which you want to find the autocorrelation. For example, here I have taken sales data for day 5, and here I want to find the autocorrelation between my present value and yesterday value. Yesterday value. Right? So here there is a time gap of 1 day only. So I can simply say that here lag is equal to 1. Okay. If you want to take lag equal to 2 days, then you can also do that. It depends totally on you. Okay. So to find, oh, I have to take, yeah, okay. To find the relationship between my present value and my yesterday value, I have just made a table here. As you can see, I want to find how my sales of day 2, which is 120, is affected by my yesterday sale, that is 100 too. Okay, but if you want to find the relationship between past second value, then you have to keep these two rows empty and you have to put this 100 here. Then you would be finding the relationship between the sales of day third and the sales of day 1. Okay, so you can find the relationship between values any two value of different time frame. It totally depends upon you. Okay, that is simply given by auto correlation. And now again you have to just put all these values into this particular formula to find the autocorrelation. Now, first again you have to subtract each of the point from its mean. So that simply mean you first have to calculate this particular mean. I have already done that. Then you have to subtract each point, 100, 128. Here you have subtract, and after that you have to multiply these two values. I have multiplied, and then you have to again square these, and then you have to divide these two terms, and then you would be able to find the autocorrelation. I already explained you these calculation earlier, so I'm not explaining in depth again. But the main thing is here autocorrelations came out to be 0.61, which is closer to 1, which gives us the proof that my present value is positively autocorrelated my yesterday value. So that simply means if sales were higher yesterday's sales were higher, then my today's sales will also going to be higher. If yesterday's sales were low, then today's sales will also going to be low. So in this way, we can find the autocorrelation between any two dates, and after finding that, we can just conclude that how my present value is affected by that particular value. Okay, that gives us the autocorrelation. So I just wanted to explain you autocorrelation, and to explain that I had to take this long route. First, I explained you correlation, and then we jumped into the autocorrelation. The autocorrelation basically simply means how past values of a time series influenced by future values. Okay, now these are the points, you can just read them. Okay, then the next characteristic is, okay, again I have given you one table here. So if the autocorrelation comes out to be 1, then simply means today's sales are exactly equal to yesterday's sale. If it came between 0.7 0.1, wrongly. 0.3 0.7, not have enough evidence, somewhat. If come out to be 0, weakly influence, and then you can just view this table in simple words. You just need to find it if it is closer to 1 or -1. That will give you the answer. Okay, now the sixth characteristic is stationarity, and I'm going to talk about this particular characteristic in my next video in full detail, because it is a very interesting topic. And to understand the time series data, you have to grasp stationarity topic in very depth. So I'm going to explain this particular topic in my next video. For this particular video, I'm just going to I'm just going to give you the point that you have to cram. That stationary time series means constant mean variance, constant autocorrelation. I'm just going to give you this. Okay, what it is and why we need to study it, I'm just going to explain it in the next video. For this, you just need to have it in your mind that stationary matter a lot, because all the machine learning algorithm in time series assumes the stationarity, that your time series should be stationarity, only then a machine learning algorithm will able to predict. So stationarity is very important. Now, seventh, irregularity, the last characteristic. So, so uh, to explain noise or irregularity, I think some of you would have already knew about it. What is noise, what is outlier, what is irregularity. So basically in real time data set, you won't get ideal time, you won't get ideal observations like here. We are getting this kind of observation, but in real time data sets, there always be some kind of noise or some kind of fluctuation in your time series. Let me give you a very simple example. Suppose you have opened a shop near a temple. Okay, and usually your sales are nearer to about 2000, 3000 rupees, and one day, suppose school visited that temple with all its students. Now, as thousands of students came to the temple, they also purchased some things from your shop. As thousands of new customer approach your shop, your sales shoots up to 6,000. And now, if you were to draw your sales pattern, then you will see that 2,000, 1,000, 3,000, 4,000, 5,000, 6,000. Usually your sales were like this. And one day it just jumped to this. And again, the sales were like this. Now, this particular thing is called noise or irregularity. Why it is called noise? Because it is different from all the other values. And it is so different that we just want to get rid of it, because our machine learning algorithm is not able to understand why the why this sharp peak come between this time series. Okay, now let me just give you one more thing, that here we know that why this particular sharp peak came here. It because thousands of students approach your shop. Okay, so we know the reason of this particular noise, but the actual noise is when we do not have any idea why this is happening in our time series data. What I'm trying to say is that if you get a if you get a data, okay, and you made a line plot of it, and this line plot will is like this line plot came out to be like this. Now you don't know why the sales pattern are like this, why it has two sharp peaks. You do not have any reason to support it. Then these two peaks are called outliers. They are called noise. They are called irregularity. So the real irregularity, the real noise is those observation we do not have any kind of support, and you have to get rid of them. Okay, so in real world data contain random fluctuation called noise. These are unexplained disturbance. We do not have any explained reason for them. Okay, now what characteristic of noise? Unpredictable. They do not have any predictable behavior, like we do not know when this particular pattern is going to repeat in future, and these are random sort of effect. Examples, like you can see that the sales were like this, and one day it jumps to 400 and then came back again to the normal values. And last, if noise, if sudden increase is random and no identifier cause. The real noise is that value, that observation we do not have any identified cause. But we cannot call any observation noise just because it is different from all the other observation if we have reasons to support it. For example, if you have you have a market campaign and you give your customer a huge amount of discount, then definitely your sales will be higher. Now here you have reason to support your higher sales pattern. So if you have reason, then you cannot call it the pure noise. Okay, I think you are getting my point. Now let's come to the recap part. So first of all, we studied about time dependency, that our in time series data, the observation are dependent on time, and the observation could be dependent on its parts values, all the past values. Now again, trend is the long term upward and downward movement of the data, and we definitely want to know about them, because we want to know for a business perspective, are my sales is going upward or in downward direction in the long run. Seasonality, the patterns that are going to repeat again and again at regular time intervals, these conclude seasonality. Cyclic pattern, the patterns that are going to repeat again, but we do not know that after how much time they are going to occur again. So in seasonality we have a regular time period. Cyclic patterns, no regular time period. We do not know anything about them. Stationarity, I'm going to discuss it in next video. Autocorrelation tells us, basically give us a number. It gives us the number between to -1 to 1, which gives us how my present value is affected by my past values. Okay, more it is closer to 1, positively correlated; closer to -1, negatively correlated. At last, we have studied about noise and irregularity. So, which simply means a data point which is different from all the other point that contains, that is actually the noise. So, with that, I think I have explained you all the concept. Let us jump to the practical part. Uh, okay, so I have already shown you that I have imported the data. Now, time dependency, all the observations should be dependent on the time. Here you can see that all the date are in particular order. You can clearly see it 1, 2, 3, 4, and all the observation are dependent on past values. You can clearly see that here the time is decreasing, increasing, decreasing, and you just need to draw a line chart and you can just clearly see that. Trend and seasonality, here you can see that seasonality is there. This particular pattern upward and downward is repeating for each year. So we can say that our dead time has some amount of seasonality in it. Autocorrelation, yeah, To find the autocorrelation between any two values, you just need to use this particular code. Okay. Now I have used lag equal to 1 here. You can put any lag. If you want the find the relationship between our present value and my last 10th value, you can just put 10 here, and this will give you the value between -1 to 1, and after that you can find the inside. That's how your present value is affected. Okay. Here it comes out to be 9.7, 0.97. That simply means my present value is strongly influenced by my past yesterday's value. Okay. Now I have also find trying I also find the uh autocorrelation for different lags. As you can see here, I yeah, for lag 2, lag 3, lag 4, and the autocorrelation for different lags is written over here. Like for lag 2 it is 0.95, and you can clearly see that for different lags the autocorrelation is decreasing of as you increase the lag. And it is also making sense because my present value is not going to be influenced to not going to influence that much with my last 10th value. Okay. Previous 10th value. So the autocorrelation is decreasing. Okay. You can just find it out with the help of this particular code. Okay. Now I'm going to talk about this particular graph in my next video. Sorry. And we are going to talk about it classical decomposition in our next videos. So for this video, I think I have explained you all the concept, and thank you for bearing with me, and thank you for just watching my video. I hope I would be able to explain you all the things in a very simple language. I know my English is not up to the mark. I stuck sometimes because I'm not a native speaker, but I'm trying to make my videos in English. And I think if my videos in English are going if my videos got a good response in English, then I'm going to continue to teach in English. Otherwise, I will switch again to Hindi because I think the main motive of making videos, my main motive to make these videos is to make you understand these concepts in an easy language. I don't understand why I need to choose between Hindi and English. I'm just doing it for you because most of your comments showed me that I need to make videos in English because many viewers were not able to understand Hindi. I don't know why. They are living in India, but they are not able to understand Hindi. So sorry for all these things, and see you in the next video. Bye bye.